Yes, Nontle. Not Nontle, but Nompe Kalanga. Yeah, you sent us a very nice question here. Thank you for sending it through. This one covers everyone, like grade 10, grade 11, grade 12. You want to see how do you work with a question like this. It's across the board because it's an analysis question. When you've got two graphs drawn on the same set of axes and we ask you a whole lot of questions around those graphs, what would you need to do? For grade 12s, I hope now you are happy with inverses and functions. Those ones, very, very nice. Maybe the only thing that I was hoping to see from your questions is how do you restrict the domain of a parabola so that its inverse becomes a function, where you will then say it must only be from x is less than or equal to 0 or x is greater than or equal to 0, so that you chop off one leg of the parabola and then you left with only one leg. But then this is what you wanted us to look at, which means what I'm saying is a parabola looks like this, and its inverse does not become a function, because if you draw the inverse, it's going to look something like that. And if you draw a vertical line, it cuts it twice. Remember, we use what we call the vertical line test to test if a graph is a function or not. If the vertical line cuts a graph twice or more, then it's not a function. It must only cut it once, right? So this is a function, but this is not a function. So if you have this and you want its inverse to also be a function, you lose one leg so that you're left with only one leg, and then when you reflect it by the line y equals to x, and then you're going to have it's actually reflecting the other direction, because it doesn't do this. It does this. Very important. So your parabola looks like this. I know this looks like a terrible sign of some football team. Not that football team. This parabola. If you're reflecting it, it doesn't do this rotation. What it does is it does that, right? It flips around to produce the inverse. And when you draw a vertical line, it will cut it more than once, which makes it not to be a function. So if you want it to be a function, you lose one leg so that you're left with one leg, and then when you reflect it, you then get the vertical line to cut it once. I was hoping to see for those kinds of questions, but then your textbooks will clarify more on that. And if you still have those kinds of questions, send them through. We are waiting for them. We are up and running, ready for them. Right. So Nompe's question, it's a nice one. You want to see this one. It's a very powerful question. It's going to explain a lot of things to you guys. So it reads as follows. It says sketched the graphs of f of x is ax squared plus q. So grade 10s will also appreciate this one. You will also appreciate this one. Right, I told you it's mathematics. We do everything for everyone. So it's actually ax squared plus q. That's f of x. And we have g of x. And apparently g of x is given by, oops, look at that, 1 over 2, right, to the power of x minus 4. Ooh, looks very intimidating. Okay, but now you already know that the one is a parabola and the other one is an exponential graph. How do you identify an exponential graph? Well, it has an exponent on it. It's a variable x. The input values are exponents. Very important. Now, the drawing for these looks as follows. Let's try, first of all, with this guy, whom is the parabola. So the parabola looks something like that. Okay, I don't know why I used white for this guy, but it's fine. Let's get on with it. Okay, and we have the Cartesian plane passing through there, and we've got the Cartesian plane also passing through somewhere there, right? And now we know, again, something very interesting, that there is another graph which passes through this point here that looks like that, and it does that. Aha! Now you can already see which is which if you know your story. That's why it's important for you to understand the defining equations of these graphs and the corresponding shapes of these graphs. So allow me to extend my quadratic function, because they then intersect somewhere there. In fact, I have to go even lower. Right, some of us guys are not good in terms of drawing. That's why we are doing maths, because maths is not difficult. That's why I'm doing it. Okay, and then after that, we're going to get to add something else as far as this graph is concerned. And there's a dotted line here that looks like this. You guys should know what is the meaning of the dotted line. That is what we call the asymptote of the yellow graph. That's the asymptote of the yellow graph, right? So these graphs are meeting each other here at the point which is given the coordinates. It's actually named point A, no coordinates given. There's O here, the origin. There's point B there again, where the parabola is passing, and the parabola is also cutting another point E, and the coordinates of point E are given to us as 1 and 3. Okay, we see you, Nkalanga. All right, cool. And then this graph tends at point C, right, which lies on the y-axis. And the other thing that we're told that C is the turning point. Yes, C is the turning point of the graph of f, and D is the y-intercept of the graph of G. So the yellow graph passes at point D. It cuts the y-axis at point D, right? So this is a typical exam question that you might even find in your final exam. It's a nice question. It's based on a lot of concepts. There's a lot of things that we can talk about as far as this graph is concerned, or this combination of graphs is concerned, right? So the first question says we need to write down. Now be careful of those kinds of words. Write down the coordinates of D. Okay, the coordinates of D. Just because they say write down the coordinates of D doesn't mean that you can't calculate them. I know what the coordinates of D are going to be, right? I know. They're going to be -3. They're going to be 0 and -3. But they're saying write them down. Let's explain to you where that -3 comes from. So you go into the diagram, you locate point D. Point D, we're told that this the y-intercept of the graph. Now, like I said before in our first question, there's a lot of things I know on these graphs. For example, I know at point C, the coordinates there, its x-coordinate is 0. I don't know what the y-coordinate is. I know at point D, at the bottom there, it is where x is 0. Even though I don't know what the y-coordinate is, I know for a fact that the x value is 0 there. So what I'm going to do is I'm going to use my algebra and take that 0 and substitute in the equation of the yellow graph to ask it, what is y when x is 0? So I'm going to say we know for a fact that y was given to us as half to the power of x minus 4. So we want to know what is y when x is 0. That's essentially what we're asking here. And anything to the power of 0 except 0 to the power of 0 is 1. So we are sitting with 1 minus 4 here, which gives you a value of -3. That means if y is -3, then the coordinates of D are going to be 0 and -3. Like I said, update the information in your diagram because it will help you as you move forward. So you can either put them in point form like that, or you can even write explicitly that this is -3. All right. What is the other thing that I'm interested in putting down here that might help you? What is that -4 in the defining equation of g of x? That -4 always gives you the asymptote all the time, right? As a matter of fact, the equation, right, of the asymptote is always y is equals to whatever that q value we have there. Since it's -4, I know it is y equals to -4. That's how I could figure out that it's going to be -3, right? Okay, cool. So I've got the first question answered. The coordinates of D is 0 and -3. The second question is asking for the range of G. The range of G. The range is asking for the values of y, the y values covered by the yellow graph. So on the far left, I'm going to extend my asymptote and show you that this graph does not exist below the asymptote. There's no graph. The yellow graph is only defined above the asymptote. So think about it. If this is my asymptote, my graph is sketched above the asymptote, which means the y values that this graph covers are all values that are above that asymptote. It is always the case. Either your exponential graph will be above the asymptote or it will be below the asymptote. If it's above, you're going to say y is greater than the asymptote. If it's below, you'll say y is less than the asymptote. So that's actually what I'm going to say all the time. So now this one is above the line -4, so I'm going to say it's here, right? That's where the graph is, which means the solution to the range of this graph, I'll say, well, this is an easy question. The range is y is greater than -4. Please don't say greater or equal to, because you cannot include the asymptote since the graph does not reach the asymptote. Asymptote is actually a set of points that the graph will never reach. It will keep getting closer and closer and closer, but it will never get there, right? So please just say y is greater than -4. Alternatively, you could have said y is the element of, and then you put -4, and then you put positive infinity. Both of them are not square brackets because I'm not including them, right? You can even use inequality notation if you like, but these are also popular notations that people use to answer that question, right? The next question now. The next question says to us, we need to calculate the coordinates of point A. So let's go and check point A. Like I said before, look at point A and look at point B. I know something about them. I don't know why you guys struggle with graphs. I know something. What do I know? Well, I know for a fact that the coordinates of point A have a y value on them of 0. And B, both A and B have 0 on them. If you also want me to write the coordinates of A, I don't know what x is, but I know for a fact that the y coordinate anywhere on the x-axis is always 0, right? So what I'm going to do is I'm going to take that 0 and substitute again in the original equation of the yellow graph, because the yellow graph does pass through point A. I can't use the white graph because the white graph, which is the parabola, has an incomplete equation. It only has ax squared and q. I don't know much about the defining equation of f of x, so it's not going to work for me. So f of x will not work for us, right? But the graph of G has got a lot of things on it. There's a lot of things we know about it, so it's going to be the best graph to use to try and find the coordinates of A. So what I'm going to do, I'm going to ask it, I'm going to take that 0 of y and replace it by G and ask the graph, what is x when y is equal to 0, right? Now, this is where your skills of logarithms might also work. We'll do it in two ways, right? The grade 10, 11, and 12, the grade 10, 11 style, and then we'll also do it using logos arithmos, right? Which is logarithms. Very powerful. So what I'm going to do, I'm going to say we know that g of x was given to us as half to the power of x minus 4. We're looking for the coordinates of A. We know that g is 0, which is as good as y. Remember, g and y is the same thing. So if you replace g of x and you write this as y is half to the power of x minus 4, you're essentially doing the same thing. So at point A, the y value is 0. At point A, you guys will notice that the y value is 0 because anywhere on the x-axis, y is 0. Okay, so this is going to be half to the power of x minus 4. So I'm going to apply my laws of exponents to nail this question. I'll add 4 on both sides, which is as good as transposing 4 to the left. I'll have half to the power of x. I'll change this to exponential form, my fraction. It is 2 to the power minus 1 to the power of x. When you've got same exponents, grade 9s will tell you you must multiply them. It's 2 to the power of minus x. And I'm going to change my base 4 to base 2. It's going to be 2 to the power 2 equals to 2 to the minus x. If the bases are the same, we can equate the exponents. That means that I can then say that 2 equals to negative x. And then from there, you guys will agree with me that x is going to be negative 2 because you divide both sides by negative 2. Therefore, that makes the coordinates of A to be negative 2 is 2, 0. Very powerful stuff, right? Now, if I know that, I can then go back to my drawing. This is simple algebra that you guys should be good at and substitute this as negative 2. Suppose you wanted to do your laws of exponents to find that. Not laws of exponents, but your newly learned skill, your exponent, your logarithms, to find the value of x. So 0 is half to the power of x minus 4 because on the x-axis, y is equal to 0. I'm trying to solve for x. I'm going to take 4 to the left or add 4 on both sides of the equation. That is correct mathematics, mathematical terminology. So I've got half to the power x equals 4. Now I want x to come down. I want x to come down. What do? Well, you log in first. So let's try to log in. There's a shorter route, like I said, but short things are not nice. You know, you need to learn the proper mathematics and understand how this thing works. So I'm going to log in. I log in on the left. I also need to log in on the right-hand side. Right? I just did the log of 4 equals to the log of that half to the power of x. After logging in, what can you do? Well, after logging in, you can download that exponent. So let's download the exponent. What are we going to have? You'll get log of 4 is x log of half. And then after doing that, then I can say I want x to be left alone. I don't want that log half. So what I'm going to do is I'll divide by it on both sides. So I'm going to divide by this guy. So I'm going to say over log of 1 over 2, even this side over log of 1 over 2. That divides off. Remember, log is not considering log alone. The whole log half is a function that goes with the argument. It's log and its argument, right? It's going to be, look at that. On the left-hand side, I said I don't like too many logs. If you've got too many logs, you can represent them with one log. You've got that 4, and that number that comes on the denominator becomes your small half there. So let's type this and see if it's going to really give us minus 2, so that we confirm that indeed the mathematics is actually the same. All right, so you push the log button, top right corner, below the on button, top right. You push that, it gives you 2 boxes. The base has to be half. That's what you call the base of our exponent. I'm going to create a fraction there. You guys have got nicer calculators that can do anything for you. Right, there's my base, it's half. And then I get into them brackets by pushing the right-hand side arrow to go to the right. And then I can put 4 in that bracket. Then I press equality. Look at that. Bam, we get x is minus 2. Right, x is minus 2. Very exciting indeed. That confirms that indeed the coordinates of point A -2 and 0. So if you are watching the show, you can now get back to school and surprise your educators if they didn't teach you how to work with exponents. Show them how to solve unknown exponents using logarithms. A very powerful skill, only available on Tenfold Live. So keep watching the shows, guys. We're doing magic here. We're doing nice things here. So keep watching. Right. Okay. So I'm going to move on to the next part of this question. Remember what I said? I said if you know the coordinates of A, then it means you can also know the coordinates of B. And it's nice because the next question does touch on that, right? Think about it. This is a parabola, right? That is the one that you guys were looking at in grade 10. And it's symmetric by the y-axis, which means the y-axis divides your parabola into two equal pieces. So I'll say two things I said. First of all, I said this kind of a parabola that you were looking at, the graph of f of x, right, has got the same x-intercept on both sides of the equation of the y-axis that are just opposite in sign, which means the distance from the origin, we know that this distance here, right, is the same as the distance from O again to B, because the axis of symmetry for the white graph is the y-axis. This graph does not have any shifts moving left and right if you compare it with the mother graph that you learned in grade 10. That means if the x-coordinate at point A is -2, what is the x-coordinate at point B? Yes, I can hear somebody saying it somewhere that it has to be +2. I'm going to put that in without even doing any calculations. And like I said, keep updating your diagram. You'll be able to do a lot of very exciting things if you know those coordinates and you can see them in your drawing. So knowing what the x-coordinate of point A is, and it's all thanks to your yellow graph, I can take that information and transfer to the coordinates of point B. There's coordinates will always be the same if your graph is only symmetric by the y-axis. But the distance from the axis of symmetry to the left and to the right of the graph is always the same all the time, irrespective of where your graph is. They are equidistant all the time. Right. Keep that in mind. I hope this is actually empowering you to some extent. Right. Now the next question is asking us to calculate the values of A and Q, small a and small q. What is this small a and small q? Let's go back and check from the given stuff. What is small a and small q? There they are. So the examiner is interested in small a and small q, which happen to be the parts of the defining equation of f of x. Look at f of x top left. The small a is the coefficient of x squared, and the q value is the y coordinate of the turning point. We know this. We should know this. But it doesn't matter what it is. I'm just going to use my algebra to try and figure out what is the value of A and the value of Q. Right, now, this actually takes us to what we have already spoken about, which is the methods of finding the defining equation of a quadratic function. So if I have to find the defining equation of a quadratic function, I'm going to draw your attention to two possibilities. Sometimes we give you a graph, right, that can be anywhere, and we give you the x-intercepts. Okay, let's start with this one. We give you the coordinate of the turning point of the graph, and we give you some random point somewhere. We give you this, and we also give you that. If we give you this setup in an exam, or you happen to have this information, you have the coordinate of the turning point of a parabola, and you have a random point, you will need to use y is a into x minus x plus p. It's actually x plus p squared. Let's write that neatly so that you guys can see what is going on. I've got the coordinates of the turning point. You should know that the coordinates of the turning point are p and q. So you're going to use this x plus p squared plus q, right, as your starting point in attempting to find the equation, because the coordinates of the turning point are always negative p and q, right? Because you'll then take this number and substitute here, and take that one and substitute there. And of course, your random point will be having some y and some x, which you can then take this x and replace it by x, and take that y and replace it by y, and solve for a, and finish off finding the defining equation of a parabola. I'm just adding more value for you guys to understand how do you find the defining equation if a parabola is sketched for you. The other case of a parabola is when they don't give you the turning point, but you happen to have the x-intercepts, right? Which means you've got some x value here, which I would like to call x1, and some x value here, which I would like to call x2. And then you also happen to have another random point somewhere with some funny coordinates, which we can then call x and y. So if this is the setup, what will be your approach? Well, your approach will not be the turning point approach, but you will then use y is a into x minus x1 into x minus x3. There's a third case which I won't talk about because of time, of when you've got 3 random points where you'll have to find 3 equations and work with them simultaneously. But for the sake of case 2, this x1 here, the x-intercept that you guys see here, will be replaced or substituted here where you see x1, right? And the second x2 that you see here, you will replace it there where you see x2. I don't know why I like writing x3. Right. There's x2 actually, not x3, x2. Okay, fine. So x1 and x2, you replace them by x1 and x2. So those are x-intercepts. And then your random point will then come and be substituted for x and y. So that x value will come here. It works extra time, this one. It works OT, over time. It works twice. You put it there. And then you substitute your y there, and then you try to solve for a, and then a lot of algebra comes in, and then you find the solutions from that. So between these 2 cases, which one do we have in this drawing, right? Let's go back to our sketch and check it. Do we have case 1 of knowledge that involves the turning point, or do we have case 2 where we know the x-intercepts of the graph, right? Let's go back and check this. Now, if you look at the white graph, pay attention to the white graph. Pay attention to the white graph. You will notice that the white graph passes through point A and point B, which we know the coordinates of, and those happen to be the x-intercepts. In addition, we know that this white graph passes through point E with the coordinates 1 and 3. What does that mean? That means, well, I've got my random point, which is 1 and 3, but the important thing is I've got x-intercept at -2 and +2, right? So I'm going to use that idea. Which idea is it? It's going to be this one, right? Let me just rewrite my drawing. It looks like this. That's the white graph. And that white graph happens to pass through here, where there's -2. It passes here, where there's +2. And it passes here, where there's coordinates 1 and 3, which are the coordinates of point E. And all this is given to us by the examiner. We have to find the equation of this graph. So what am I going to do? Well, I'll use the second case format, which means I'm going to say the equation is y is a into x minus x1 into x minus x2. And then I'm going to write y equals to a into x minus. Now look at that. It's minus of -2 because I need to replace this here. Minus minus is going to give us +2. Very powerful. Okay, cool. Into x. Now minus the second one is actually minus the second x value is 2. So I'm going to put that 2 here. I've just succeeded to substitute my x-intercepts. Okay, those are done. Now, what's the purpose of the random point? So this random point, which is the point E, will be what I replace for x and y. And pay attention to what is going to happen. Wherever I see x, I'm going to put 1. Wherever I see x, I'm going to put 1. And wherever I see y, I'm going to put 3. Very powerful. Now, that means I still have a here, okay, and I still have got my values that are yellow. The yellow values are those ones where the graph passes on the x-axis, and we did find them as -2 and +2. So this is actually what we end up with. The yellow numbers come from the x-intercept. The green numbers are the coordinates of the random point that was given. Notice that that one works extra time. It's working OT, over time. Okay, cool. Now I'm going to simplify and solve for a. So this is going to be 3 equals to, you're going to have 3 here, right? So I have got a into 3, okay, times, this one's going to be 1 minus 2, which is -2. Okay, not -2, but -1. Come back, Schofield, right? Yes, it's going to be -1 because 1 minus 2 is -1. And when you multiply that, you get 3 equals to a times -3, which is just -3a. You divide both sides by -3. Your a comes out as -1. I'm happy to see this because that means I am dealing with a set face parabola, the one that is facing down. If I got a positive a value, I was going to be very worried because it will mean that my parabola must smile, which is not supposed to be the case. So in fact, let me remove this smile because it might confuse you. It's a smile of excitement, but then I'll just leave it like 1 as it is right now. Okay, cool. So our a value is -1, and we're happy that we found that. So we can go back now and resubstitute this information. In which line? You're going to put it in this line. This is the line that you always use because it's the line that will have y, the a value, the x1 value, and the x2 value. That is where you will always take yourself back to. So which means I'm going to write now that I've got y equals to, I've got -1 into x plus 2 into x minus 2, from which I can then simplify and factorize. And I'm doing it like this because I'm trying to cover all other possible questions that you might get. I don't want to use a method that only works for grade 10s, even though this is based on grade 10s work. Right, So I want to use a method that covers everybody across the board. So it's x squared, and then if you multiply, this is the difference of two squares. Grade 9s will tell you that must be x squared minus 4. If you multiply by the minus 1, you're going to get minus x squared plus 4. I hope the math is fine. Okay, no, I don't know why you would be sad at this. This is actually exciting stuff that you did find the correct solution, and that is the correct equation of the graph of f of x, which means you can then compare this with what was given to us. Remember, we were given that f of x is ax squared plus q. Then you can clearly see that according to this, that's your a value there, and according to this, that's your q value there, which means my a is equals to -1, and my q value is equals to +4, and that is the solution to the other part of this question that you wanted us to look at. It helps you to understand how do you find the equation of a parabola. I gave you two cases. It might not be this in future. So this is Tenfold Life. We don't want you to just be limited. We want you to be exposed to all possibilities. So when you get the other questions in future that are not the same as this one, how would you work your way around that? So this is how you would need to do this. If it's 10 points given, the approach is different. If it's x-intercepts given like this one, the approach is going to be exactly what we just did on this question. All right. Okay, now the next question says we need to determine the length of CD, and we need to find the equation of the line AD. Right. Oh, God. This is beautiful stuff. The length of CD. Let's go back to the drawing. The length of CD. What is CD? I'm going to ask you to allow me to delete some of the things we have so far, such as the calculation on the right there. So we have space because I want you to look at the diagram as I do the analysis to this question, right? And in Kalanga, I hope you are watching. I hope you're watching. So CD, we want the length of CD. Sometimes you might need to use the distance formula if you are dealing with lines that are either lines that have got positive or negative gradients. But for a vertical line or a horizontal line, you don't need the distance formula. So pay attention to where point C is located. If I redraw these graphs, I've got a parabola, right? And I've got an exponential graph. And they both lie on a straight line that happens to be the y-axis, right? In that form. And if you just focus on them, the turning point of the parabola is point C, and the y-intercept of the exponential graph is point D. And the examiner wants me to find the length of CD. So the length of CD is how long is C from D, and remember distance is not negative. So we're just asking you how far is point D from point C, or the other way around. Now since we found that the equation of f of x is -x squared plus 4, that simply means that we can conclude that the coordinates of C are 0 and 4, because this is basically going to be the q value on a graph that looks like this. It's actually the y-intercept of the parabola, right? So if this point here is 4 and this point here is -3 from our previous calculations, we did find that the y-coordinate at point D is -4. We're asking you how far is this one from the other one, right? And we are asking in terms of distance, not in terms of the actual value -3. So remember that the y-axis is somewhere. I don't know where the x-axis is, but let's just assume that the x-axis is here. You will notice that to move from D, right, to the x-axis, you will move 3 units, right? And to move from the x-axis to C, you will move 4 units. That means in total, the length of CD has to be 7 units. You don't even need any fancy calculations to work this out. By just observation, you can see the movement from point O, the origin, going down to point D will take you 3 steps in total. Distance is never negative, so we're looking at 3 units, right? And to move from the origin to point C, you're going to move 4 units in total. So the total distance between point C and point D is just going to be 7 units in total. If you wanted to work with it algebraically, maybe you are one person who likes algebra a lot and you like formulas, you can then say CD, right, is the y value at point C minus the y value at point D, okay? Which I'm going to finish off here and say CD is the y value at C, which is 4, minus the y value at D, which is -3, and I promise you that is going to lead you to 7, and that means the length of CD is just going to be 7 units. I hope that helps you to understand how do you work out the length of CD. The next question is asking for the equation of the line that passes through point A and point D. Point A and point D. Right. Now, I want to say this. I want to state this. Very important, guys. Graphs are limited to finding Y-intercept, finding X-intercept, finding asymptotes, finding turning points, full stop. That is graphs. Anything beyond that is not graphs anymore. In fact, the reason why you guys struggle in graphs is because it's not because you don't understand what is going on with graphs. You guys know how to find the Y-intercept, you know how to find the X-intercept, you know how to find the turning points of different graphs, you know how to find the asymptotes. If you know how to do that, you understand graphs. That's what I want you to understand. You understand graphs if you know how to do that. But when we start asking other questions, like this question of the distance between C and D, that question has nothing to do with graphs. If you knew that at the turning point, the Y value there is 4, it's just distance, which could be associated with analytical geometry. So what gives you problems is when we integrate math concepts with graphs, when you take other concepts of math and integrate them with graphs. That's where you guys start struggling. You must know this. Mathematics is not a field that contains islands of information that are disconnected, right? It's not disjoint technical facts. Math is actually, if you think of it in terms of those islands, just imagine as if there are bridges between those islands where you can move from one island to the other, which means you can use one concept in another island to solve problems there, right? So when you're doing graphs, you're not limited to Y-intercept, X-intercepts, turning point, asymptotes. You're not limited to that. You might also need to know other information like how to find a gradient. A question about a gradient has nothing to do with graphs. It's not a graph question. It's a question that is from analytical geometry. If I was naughty, I was going to start introducing straight lines and asking you for angles in paper 1. And people will struggle. Why? Because they're not expecting me to ask them about angles in paper 1. That can happen. If you're asking me about angles, I've got lengths of sides, I will use my trig. Nothing wrong with that. So please pay attention to that. Don't think about it as if it's a skill. We are testing a skill. So the next question is asking for the equation between point A and point D. What skill is being tested? They're testing your ability to find the equation of a straight line. Is that a concept of graphs? No. What concept is it? It's a concept of analytical geometry. Here, the only purpose of graphs is to help you find the coordinates. So this is maybe where you see when you've got those 7 marks, 6 marks questions, where they just appear and say find the distance between point A and point B in a graph, or find the equation of the line that joins A and D. Then they want you to use your graphs to find the coordinates. And then after that, once your graphs have helped you to find your coordinates by using Y-intercepts and X-intercepts, then analytical geometry takes over to help you work out the equation of the line. So please pay attention to that. The skills is what we want you to have, and apply those skills when you're working with this concept. So let's go to this one and see what the story is. There's point A there. Point A on the left-hand side of the Cartesian plane. That's where both graphs meet each other. The coordinates there, we found them to be -2 and 0. So this means if the examiner just appeared from nowhere, gave me the equation of the yellow graph, and then asked me to find the distance between point A and point D, or like they did in this question, asked me to find the equation of the straight line that joins point A and point D, then I would use my distance, my knowledge of analytical geometry to work out the equation, but then that will have to be followed by your knowledge of graphs, which will require you to find the coordinates of point A and point D. Very important, right? So let's do that. Let's do that quickly, guys. Let's go back here and create the space here. So allow me to reproduce that, just the part that you're interested in, right? And I'm not going to draw the white graph because the white graph is over, it's finished. I want you to draw the exponential graph, right? Why? Because it is the one that happens to pass at point A and that happens to also pass at point D. Remember, we found the coordinates, which means in another exam, you might find the examiner comes and says g of x equals to half to the power x minus 4. Find the equation of the straight line joining point A and point D. That could be a question, right? Now, for you to find that's the equation of a straight line, you know analytical geometry will help you to do that, but you will need to use your graph knowledge or your graph theory to find the coordinates of A and the coordinates of point D in order to find that straight line. Let's introduce the line. Let's introduce the line. So here's the line that the examiner wants you to find the equation of. They want you to find the equation of that blue line, right? We want you to find the equation of that line. Now, for me to find the equation of a line, you should know from analytical geometry that the equation of a straight line is found by finding two things. We need two things, the ingredients. right? These are the ingredients. The ingredients you need are, you need a gradient of that line, and you need a point that the line passes through. Those are the two things you need. If I've got a gradient and a point, I'm then going to resort to using y is mx plus c to find the equation. If I don't use y is mx plus c, then I'm going to use y minus y1 is m into x minus x1. And this is what we learned a lot in grade 11. Grade 11s use this format a lot. They use this type more than the y is mx plus c. But it doesn't matter. It depends on who's teaching you, right? When I teach my grade 9s and my grade 10s, I show them y is mx plus c. When I get to grade 11, I introduce y minus y1 is m into x minus x1. But it doesn't matter which one you use. Any one of them will help you to find the equation, right? But the important thing is the ingredients you need. You need a gradient and you need a point that the line passes through. So let's go back and check, do we have all the ingredients we need? If you look there, you will notice that we do have 2 points, right? I haven't really written the coordinates of them, but I'm going to start by doing that, and then we'll discuss the story of finding the gradient and finding a point that the graph passes through. Now, if this question only came like this, you would then use your g of x to help you figure out the coordinates of a, right? By making y 0, you would then get -2 as the x coordinate. You would then substitute x as 0, you'll get the y coordinate as -3. But we have already found these. We've been discussing this question. Okay, cool. So I've got those equations. I'm happy with what I'm looking at right now. I've got the coordinates of both point A and point D. I can then start doing a lot of very exciting things here. So the point, which point am I going to use? Well, it doesn't matter. Actually, I'm going to take point D with the coordinates 0 and -3. I don't like using A. It doesn't matter which one you use. Both of them would work. I want to use point D, not point D, Schofield. Point D, not point B. Right? This is going to be point D. Very powerful. D point. Right. D point with the coordinates 0 and -3. Okay, cool. Now, again, the other thing that you should know, this is extra stuff. The equation of a straight line is going to be y is mx plus c. So this line is going to be y is mx plus c. But you should know by now that the c value represents the point where the graph passes on the y-axis, which means I'm expecting c to be -3. I'm expecting this here to be -3. So I already know that this equation must be y is equals to mx minus 3. And I'll do it using that method later on. Let's start doing it the analytical geometry way first before we get to that, right? So analytical geometry says we need a gradient to find the equation of a straight line. So let's calculate the gradient. How do you work out the gradient? Well, the gradient of any line is given by changing y, which is y2 minus y1, over changing x, which is x2 minus x1. This is what we call average gradient between 2 points. Right, now if I'm looking for the average gradient in this case, what I'm simply going to do here, I'm going to say my y2 is, I'll take point B as my point D as my y2. I'm going to have -3 minus the y value at point A is 0 divided by the x at D is 0 minus, and this is going to be -2. Right, what I'm essentially doing, I'm subtracting this guy minus that guy and this one minus that one there. That's what I'm doing. -3 minus 0 and 0 minus -2. The gradient that I'm ending up with here is -3 divided by +2. I'm getting a negative gradient. Am I happy? Yes, because my straight line is a decreasing line. If I got a positive gradient, I'll be very worried about my calculations or some of the things I have here. So I'm happy that I've got 0 and -3 as the coordinates of D, and -2 and 0 as the coordinates of A, which landed me with a value of -3/2 as my gradient for this decreasing blue straight line. Okay, so I'm going to come here now and say, examiner, I now know that the gradient is going to be -3.5. I'm happy with that. So I've got a point which is 0 and -3, which I'm then going to use to find the equation. So I'm going to use y is mx plus c to find my equation. I'll take the point and substitute for x and y. My y is -3, so I'm putting -3 equals to my gradient is m, which we found as -3/2. My x value is 0. Remember, whatever you're taking as your x1 and y1 needs to come from the same point. You can't take an x value of D and a y value of A. That will be wrong. And it has to be a point on that line, a point on that line. Right. And then you'll know anything times 0 is going to amount to 0. So -3 is C as I expected, which means then the equation of this is going to be y equals to -3/2 x, right, minus 3. And that will be the equation of the straight line. I just did it using the analytical geometry method. Find the gradient, find a point that the line is passing through, and then substitute that information. And then I've got the equation of the line that is passing through point A and point D. But legends who understand graphs a lot can actually find this much quicker. What they will do is they will do the following. Check this. I'll do it in the green box here very, very quickly without any challenges, right? I was going to write this. If this was me, I was going to say y is mx plus c. This is just to add information for you guys to have access to even more when it comes to graphs. Now, this c value tells you where the graph is passing on the y-axis. But the examiner already told us it passes at point D, and the y value at point D is -3. That means I'm sitting with y is mx minus 3. I immediately write it down there because c is where the graph cuts the y-axis. Now I need to find the gradient of the line. So I need any point on the graph where the graph is passing. So I'll take the coordinates of point A just to prove to you it doesn't matter whether you're using D or you're using A. Any point that you use will work. But in this case, you obviously need to use a different point, because if you didn't use, if you use D again, you're going to have problems. You can't repeat a point. You can only use a point once. So I used point D to find that C value. I'm going to A now. My X value at A is -2. My Y value is 0. So I've got 0 is m into -2 minus 3. If you simplify this, you're sitting with 0 is -2m minus 3. That makes 2m to be equal to -3. If you divide both sides by 2, you will end up with the gradient m equals to -3 over 2, which is exactly what we found as we were working out the gradient using y is mx plus c. From then, you will then say, examiner, that means the equation is y equals to the gradient x, and you've got -3 there. That's the equation using two different forms of finding the equation of a straight line. I hope this helps you to understand what is going on. I think I need water, but then it's fine because we're actually approaching the end of the show. And you guys, I hope you're learning. That's what is important here. I hope you're learning and you're understanding what is going on here. I don't know if we still have time for more values here. Oh, there is another question. There is another question here. We are told here we need to find the values of x for which f of x is greater than 0. We also need to find the values of x for where f of x is decreasing, right? F of x greater than 0 versus f of x decreasing. Remember, f of x is the parabola, right? It's the parabola. I hope you learned a lot. I'm actually enjoying myself on this. I wish we had more time, but then it's fine. Let's see what we're going to have here. We're going to go back to the parabola again. Let's go back to the parabola and look at it. They want two parts. They want x values. They say find x values. This is the analysis type of question that I was telling you about. The white graph, the graph of f of x. I'll have to reproduce it alone so that we get rid of all the mess that we have so far, right? And this type of analysis is something you can apply across all graphs. It doesn't have to be for a parabola. You could be doing trig graphs, or you could be doing a cubic graph which is coming under calculus. It doesn't matter what you're doing, right? The ideas are the same. So we want, they say find x values, right? Find x values where, first of all, f of x is greater than 0. And secondly, they want where f of x is increasing. Ah, very powerful. Right. Now, for me to do this, it's an easy question, guys. But for some weird reason, you guys struggle with these analysis type of questions of 2 marks and 3 marks and 1 marks and so on. So let's see the parabola. Let's just look at the parabola. It looks like this, right? It's sketched nicely for us. It looks like that. I'm ignoring the exponential graph right now because the examiner is interested in this parabola, right? And I'll introduce the Cartesian plane once more. This graph looks like that. Okay, fine. And it passes at x is -2 here. It passes at x is 2 here, and it's turning here at y value of 4. But I'm not interested in the y values. When x is 0, the y value is 4. I'm only interested in the x values because the question does say that it says find x values where f of x is greater than 0. Now, when f of x is greater than 0, remember what f of x is. F of x is as good as y. So this is as good as asking for x values where y is greater than 0, right? In English, people, in English, it means we want where the graph, right, is above the x-axis. Because we are looking for the y values that are greater than 0. That means we are looking for positive y values, right? And you guys will know that y values are positive above the y-axis, right? They're positive above the y-axis, right? So that means that the graph is positive here. This is where the graph is positive, right? the graph is positive here, right? Above the x-axis, right? That's where the graph is positive. So you will agree with me that this graph is greater than 0 from when x was -2 all the way until when x is +2. Because below the x-axis, your graph is negative. Below the x-axis, your graph is negative. Here, the graph is negative. Even here, the graph is negative. We want it when it's greater than 0. So the answer to the first part of the question is just simply going to be, I'm out of time now, so I'm going to say it's where, no, not this, but it's where x is between -2 and 2. And where is the graph increasing? We're asking where is the graph going up? You'll agree with me that the graph is going up this side, and then it's going down this side. It's going down this side. We want it where it's increasing, which is where it's going up. And it's all x values before 0. So I'm going to say it's all x values that are less than 0. Don't say less or equals to, just say less than 0. Right, I hope you guys enjoyed yourself. I'm very excited with what we've went through here. I hope it helped you to understand what is going on. I thoroughly enjoyed myself. There's a lot of things we discussed. And if you've been with us throughout these 3 hours, just send love on Facebook. Remember to download our app. And a big shout out goes out to Liberty. Thank you very much for watching Tenfold Live, guys. We're coming back tomorrow with physical sciences, so make sure that you watch. And now, this will be the end of the program. I hope you guys learned a lot from this. We'll probably meet each other on Thursday. So thank you very much for joining. Till we meet again next time. Bye-bye.